Imagine a time when Earth was a barren, dry planet, and suddenly, a flurry of comets and asteroids began to bombard it, each bringing with them a precious cargo: water. This is the premise of our first theory, the comets and asteroids bombardment theory. Scientists propose that during the early days of our planet it was subject to a cosmic assault. Comets and asteroids, these celestial travelers, icy and laden with water, rained down upon Earth. Picture it as a cosmic delivery service, if you will. As these celestial bodies collided with the Earth, they vaporized, releasing their precious cargo into the atmosphere. So, how do we know this could have happened? Well, the answer lies in isotopic studies. Water has a unique fingerprint, a specific ratio of hydrogen isotopes. When we compare the isotopic signature of Earth's water with that of comets and asteroids, we find a striking similarity. This supports the idea that much of the water we have today may indeed have an extraterrestrial origin. But of course, like any scientific theory, it's not without its challenges and ongoing debates. Yet, it offers a fascinating perspective on how our blue planet could have received its water. So could the water we drink today have traveled billions of miles through space, carried by comets and asteroids? Intriguing, isn't it? Now consider the possibility that water has always been a part of Earth, hidden deep within its forming body. This brings us to the theory of planetary differentiation. Picture the early Earth, a hot, molten mass in the process of formation. As the planet cooled and solidified, denser materials like iron sank to the core, while lighter materials, such as silicon, oxygen, and other volatile elements, floated to the surface. This process is known as planetary differentiation, and it's a key player in the story of our Earth's formation. Now let's introduce water into this picture. The theory suggests that water, being a volatile element, might have been trapped in the Earth's forming body. As the Earth differentiated, these trapped water molecules could have been released from the interior and accumulated on the surface, creating our oceans, rivers, and ice caps. But where did this trapped water come from? One hypothesis is that it could have been delivered to the forming Earth by hydrated minerals contained in the planetesimals, the building blocks of planets, that accreted to form our world. However, this theory is not without its challenges. For instance, how did these volatile elements survive the intense heat of the early Earth? And how much water could have possibly been stored in the Earth's interior? So, could the oceans have simply risen from within the Earth itself? It's certainly a thought-provoking theory. Let's venture beyond our solar system now, to the vast cold reaches of interstellar space. Picture this: colossal clouds of gas and dust, floating in the infinite expanse of space. These are the interstellar clouds, and some scientists propose that they might have played a vital role in delivering water to our planet. The theory suggests that before our solar system's formation, these clouds could have carried water molecules across the cosmos, eventually depositing them on Earth. Quite a journey, isn't it? But here's the catch. Given the scale of space and time, confirming this theory is no small feat. It's like trying to trace back a drop of water in the ocean to the cloud that evaporated it millions of years ago. Could our water have journeyed from distant interstellar clouds? It's a theory that truly boggles the mind. Now, let's bring the focus back to our planet, and specifically its fiery interior. We're going to discuss a captivating theory about the origin of Earth's water, degassing from the Earth's interior. Yes, you heard it right. Our planet's own fiery belly might have given birth to the serene blue oceans we know today. Picture this. In the early days of our planet, the interior was a churning mass of molten rock. As the Earth cooled down, this molten rock began to solidify, forming the crust we walk on today. But here's the kicker. As it solidified, trapped within it were lighter elements, including water. Now imagine a volcanic eruption. The intense heat and pressure of the molten rock forces these trapped elements out, in a process we call degassing. And among these elements is our star of the show, water. Over millions of years, these volcanic eruptions could have released enough water vapor into the atmosphere to condense and form our oceans. But hold on, it's not just about the amount of water. The isotopic composition of this volcanic water also matches quite well with that of our oceans, lending further credibility to this theory. So, could our oceans have been born from the fire of volcanoes? It's a fiery theory that adds another layer to the mystery. Finally, let's go back in time to the birth of our solar system, to a cloud of gas and dust swirling around the young sun. This is the setting for our final theory, where the origin of Earth's water is traced back to chemical processes in the Protosolar Nebula. Imagine a vast, swirling cloud of gas and dust, teeming with a myriad of chemical reactions. In this cosmic soup, hydrogen from the nebula combined with oxygen trapped in dust particles, forming water molecules. These molecules, upon colliding with other dust particles, could have created icy mantles, the precursors to comets and asteroids. Now, here's where it gets interesting. Some of these icy bodies could have been incorporated into the early Earth, bringing water along with them. Over billions of years, these contributions could have accumulated to form our oceans. This theory is bolstered by the fact that the ratio of heavy to light water, or deuterium to hydrogen, in Earth's oceans is similar to that found in the nebula that birthed our solar system. Ongoing research in this field continues to uncover fascinating insights, bringing us closer to understanding the cosmic origins of Earth's water. Could the water on Earth have been born in the same cradle as the sun and planets? It's a fascinating idea that brings our exploration to a close.